Welcome to Programming in Modern C++. We are in week 9 and we are going to discuss module 42, M42. So, in the last module we have talked about doing formatted and unformatted I/O using C standard library, particularly the component stdio.h. We discussed I/O with file and string and specifically introduced the notion of files and streams and their association. In this module, we are going to discuss about the object oriented stream input output of C++. How does C++ do it? Obviously, stdio.h is also available in C++, as you know, as cstdio. You can, in the std namespace, you can use all those functions, but certainly you can do things in a lot better way in terms of using the object oriented stream operations in C++. This is the module outline, which will be there on your left panel all the time. So, let us identify what are the key features of C++ I/O. There are three key features. One is most of the C++ I/O features are object oriented, like in the C stdio.h you had everything as a collection of functions, procedural. Here you will have most of the things as classes and objects instantiated for those classes, and you will deal with the member functions of those classes. So, that is what makes it really flexible and gives you all the advantages that you have. The second is C++ uses type safe I/O. That is, in C, when you are trying to say write a value, say you are trying to write an integer value, int type of value, you will have to rightly specify the format in the corresponding position. If you write %d, it is good, but if you write %s and try to write an integer value, you will have unpredictable results. And this correspondence of the type of the value you are writing and the format specification that you have given is to be managed by the programmer, which is a big overhead and is a source of a huge number of errors that have happened over time and keeps happening. But in C++, it is type safe. You do not have to specify the format to write, as you have seen. The format is picked up based on the type of the data you are going to stream, you are going to write. You just say that I want to write this, I want to read this. Compiler knows the type of the variable and accordingly chooses the right format. And if you want to change that default choice, there are also additional features given to you. So, type safety is a big feature. The third that you have is extensibility. That is, in C, if you have to write or read a particular structure that you have defined, user defined data type, so to say, like complex, you cannot have any specific function, specific format string for doing that, because the format strings were created before your your program is done. So, you have to take it component by component, always break it down to the lowest level of built-in types and do the read write. This is extremely inconvenient. Whereas, in terms of C++, you can actually use the function overloading. We have discussed enough of that already, particularly the operator overloading in terms of the streaming operators, and define your own input and output operators for your own type, and then just keep using it, and it will have all the behaviors of object orientation and type safety as you have for the built-in types. So, these are the three major features of C++ type of I/O, and that makes it really powerful. We have already talked about streams. So, just a quick reminder that it is a transfer of information in the form of a sequence of bytes. The term stream, I said, it comes from the natural water stream, and for doing I/O operations, here what you have is you have certain stream classes defined. So, if it is an input device, then it is represented by I stream, if it is typically std in, or you can have a file defined or associated as a IF stream object. You can understand that I stands for input, F stands for file. Similarly, for output you have O stream and OF stream. So, these are the classes given in the library, so that you have all that you need to do is to just specify the physical file object or the physical device with the corresponding stream type, and everything else will then come from that stream type class. So, you have already seen this, but not very consciously though. Now, again a reminder is I/O operation is a bottleneck, because I/O with the disk is very slow. So, you can do this, you can work around this if you have a low level I/O. That is what you do if individual bytes of interest, you can just put them in the buffer and flush them out, high speed, high volume you can do. But high level I/O, which is typically formatted, needs to be grouped in terms of the typical data types, and they are good for all kinds of meaningful use, because you cannot go down to low level and do things all the time. So, the streams give you a mechanism by which you can do a high level I/O with its advantages, but underlying it uses the buffers and all the padding and all those to make sure that you get the efficiency of the low level I/O. That is the basic process of the stream. So, to start with, let me introduce the stream libraries that we have. You are already familiar with I/O stream, which is this library. You can see here in this diagram, I am trying to show where basically the is a hierarchy of the major classes that are involved. So, you can see that you have your I/O stream is one. So, let me explain the notation. So, whatever you see in white, these are your classes. So, you have a hierarchy diagram amongst them. What you see in terms of boxed and red names are the standard library component. So, these are the headers that include the definitions of these corresponding classes. Whatever is in blue is what we will typically include in a user program. Whatever is green is included from these files, but we do not need to directly include them. So, if you recall into this, you will know that we have always started by including I/O stream. So, what do you get? If you include the I/O stream, then you actually get 4 streams, which we have always used, the C in for input, C out for output, and there are 2 more, C error for error reporting and C log for log reporting. Right? Since we have not worked with the files, we have not included this, but this will require to be included if I want to work with files input and output both. So, it has F stream, it has IF stream, which is input file stream, it is output file stream, and I/O stream. When you include I/O stream, it actually in turn includes these 2 headers, which we do not have to specify, which has the I stream and the O stream for input as well as output. Now, I have mentioned here another, which is I/O manip. It is a little unnatural name, with what it means input output manipulation. Manip comes from manipulator. So, this is how you can. So, if you include I/O stream, where for every data type you get a default formatting information in terms of what is the size, what is the weight to be written, alignment, and so on and so forth. But if you want to change that, you want to specifically widen the size, shorten the size, you want a left justification, you want a right justification, all of these, then you need to do this stream manipulation through this IO manip. Since we have not done this before, we did not require this earlier. So, as you can see, to summarize that, all that you will need to remember is including IO stream for standard input output, including F stream if you are doing file input output, and including IO manip if you want to manipulate the formatting for finer details. So, with that, let us take a quick look into the stream classes and objects. So, at the top you have IOS, which is the basic I stream and O stream come from there. You have in that you have the two operators which look like left shift operator for output streaming, right shift operator for the input streaming. Then you have I stream which has C in, then you have with that you have O stream with which you can do up to C out. You have seen this several times. You can at the same time do CERR for printing unbuffered messages immediately, like C out, as I said, is buffered. So, you may write quite a few things, but it comes in the console maybe at a later point of time. But CERR, it will come immediately because error is very important to report. Whereas, there is a logging C log where you can just log the things that are happening. So, it is not unbuffered, it is buffered because you do not need to look at the log at every point. Whenever the buffer is full, like the C out, when the buffer is full or when it needs to be flushed, it is put together. So, coming to stream output, there is not much to add. It is on O stream, this operator, these are the typical ways to write. Just I would like to mention that flush, suppose if you are writing, then it is being written on the buffer and you are not being able to see it on the console, because it is just being written on the buffer. So, if you want to make sure that whatever you have written is shown on the console, then you can do a flush, and the way to do this is to just output flush, like here you do a flush along with a new line. So, endl is just not a new line, endl is not equivalent to this. Endl or end line is actually a manipulator which puts a new line, but after that it flushes the output buffer. If you just use a new line, then you may find that actually the new line has been put to the C out, but you are not seeing it on the console. Right? Similarly, for kind of unformatted or character IO, you have put member function which you can call on the C out. As you can cascade your formatted IO, your object IO, you can also cascade the character IO like this C out dot put. So, basically you can make out that the result, this will put A onto the console and it will return C out again. So, this again becomes C out, exactly the same behavior which we see in terms of this operator. You have seen we have written that. So, you have seen that. So, you can again do a put C and keep on doing this, right. So, this is the basic streaming output. You can, the earlier example I showed in module 41 regarding using the printf, the same example I have now written in terms of C out, and you can see what all are getting printed. The only point to 2 points to note here, like this you will get with percentage %d in printf, and this you will get with percentage %x, this you will get with percentage %o. You do not have these in C++, because it is being derived from the type. So, if I write I, then the default format is percentage, whatever percentage %d will do, write it in decimal. So, if I want to write it as hex, what do? I just do this very nicely. You just see out hex, then this. So, what it does is it streams hex first onto the C out, sets it in the hexadecimal mode, and then when I comes, then I will be printed in the hexadecimal mode. So, you will get the print as 11, 1 1 rather, not 11, 1 1, because it is a hexadecimal value. So, these are again the stream manipulators. So, you can very simply, like we have seen Endel, we have seen flush, hex, oct are other manipulators that you can very frequently use when you have the same type of data to be printed in different other forms that you want. The other point to note is in here, if you have this character pointer, you can print it as a string by using %s. But if you want that pointer value, you can print that by pointer p, %p, right. But here, when you do it with C out in C++, when you do it with OStream, the type it knows for S is char star, and char star is a string, C style string understanding for here. So, if you output S, then it will be output as a string, you will get this string. So, how do you get the value of S, value of this pointer, which you could get as %p? You cannot get that directly. So, all that you will need to do is to erase the type information from this pointer. So, you can use a C style casting to void star, which again you should not do, you should do a C++ style casting, cast the const char star to const void star and then use it, and in that case it will not know what type of value it is pointing to. So, it will not try to interpret that, it will simply print that value and you will get the pointer, that is address of the first character. So, these are the two basic differences from whatever we know in C. In terms of user defined type, obviously you have a big advantage, because now you can define, overload your output streaming operator and put it as a friend function in the class and cascade and write the user defined objects exactly as the built in objects are written. I am not going through these details, because we have already discussed this at length earlier. This is just a comparison of how it writes between C++ and C. If you write the similar things in both, you will find that these all actually write identically, though there are some differences in cases here when you are writing float or double. The default precision of %f or %lf is different from the default precision being taken. Of course, you can change that by streaming a appropriate manipulator of precision or set precision. There is a set precision manipulator. By setting that, you can change this precision and make them identical. Otherwise, all of these will look very similar, and you can very easily, when you write it side by side, you can very easily see that all these information which you will have to have in your mind, or you have to go back to module 41 slides and check the tables that I have given and carefully construct. You do not need to have any one of those here, very simple. You just say this is a value I want to output, that is it, right. So, that gives you a big advantage. Okay. The eraser at times does not like me. Anyway, if it comes to input, it is obviously very similar. It is a stream extraction. As long as you do not get to the end of the stream or end of file, the extraction will happen successfully, and the input streaming operator can control the state of the bits that are coming in. And obviously, at this point it will be good to note that both of these operators have pretty high precedence. So, if you have some conditional or some expressions, arithmetic expression. For example, if you want to suppose I want to write C out A plus B. If I write this, it will be interpreted as, because this streaming operator has higher precedence than plus. So, this obviously is not what I am meaning. So, it is always good that when you write expressions in your input or output streaming, always put them in parenthesis to make it safe. So, now this will happen and only that result will be output to the stream. Similar thing will happen for input as well. There are a number of member functions for Cin as well, which like UAF tells you if you are at the end of the file, which you need to know. You can have character IO using get or getC, getArray. So, these are the different ways to do the corresponding operations in the iStream domain. You can read a line by get line, you can ignore some, you have read a character, you can put it back, you can see what is the character you are about to read without actually removing it from the stream and so on. So, there are number of these functions, you can use them as and when you. So, whenever you need to do something, just look up, you will find that in almost certainty I can say that it will be available in the standard library in the iStream or OStream, IFstream or OFstream for use directly. So, now let me just show you the final total example with working with the file in C++. So, like in C, you need to open the file, that is you need to associate the file with the stream. So, if I am trying to do this say for output, I am showing the example for output. I declare my stream object, my file, and that is of type OFstream, output file stream, very simple. And then my file has a method open to which I can pass the name. So, this simply does the association. If it cannot, then it will throw an exception. An alternate way of doing that would be to do it at the time of construction itself. That is, you can make out this construction is happening by a default constructor, but OFstream also has a constructor which takes the name of the file as a string. So, you can directly do the opening along with the creation of the stream object. Right. So, this will happen and then you can check if it has been, if a file has been opened correctly. Right. This will give you a true if it has been opened correctly, otherwise false. Right. So, this makes it really very simple. You do not have to do all these modes and all that. In terms of C, if you see that the stream was just a file pointer. So, which did not have any specific type for input or output. So, it is possible that you have multiple file pointers open and you mistakenly use an input file pointer for doing a fprintf or the vice versa. These kind of things will not happen here because your corresponding types are directly different. So, you do not need to set a mode because this itself tells you the mode. Right. You do not need to say that this is output, because this will itself tell you that this is output. If you have to do input, then you have to create a stream which is an object of IFstream class and the mode will be the input one. So, this is a it is a clean object oriented solution. After the opening has been done, that is association of the file and the stream has happened, then you keep on using the stream, keep on writing or reading whatever you have planned for in the formatted or unformatted manner to that using the streaming operators. Right. And finally, when you are done, then you close. So, like in C, we had the close fclose function which takes the file star pointer and closes dissociates. Here you have the close member function on the corresponding type of the stream object, and you just invoke that. If you want to specifically open a binary file, then you have a flag ios : binary, which you will have to specify when you are opening the file or you are creating the file as a second parameter. If not specified, it opens it as a text file. That is the default behavior. So, here is a small example that you can actually two examples. One is writing to output file. So, I create a default stream object, I open a file and do the association, I do a streaming to it exactly as I do in terms of cout, and that is written to that file. I do a close which will by which the association is broken and the buffer will be flushed and the file will be closed. Similarly, here I am opening a stream with my given file at the construction itself. I check if it is open. If it is open, then I am reading from my file, that is what I have written here. I am reading that and I output that. So, I am reading it as a line. So, this is a line buffer. I read it as a line buffer and output that to the std out. When I am done, I close my input file. This is the simple way. Everything else besides these few lines, everything else is exactly as you did in case of cout or cin. Now, the most critical thing is that the IO in C++ is type safe. That means, it is very difficult to make errors in the IO. It gets the format from the type of the data I have already mentioned, and for all built-in types, the overloads of these operators are already given. Cascading makes the ease of expression. You do not have to correspond the format with the type of data listed. You just keep on saying one data after the other. It happens automatically. So, it avoids the use of the error prone variadic, that is variable number of argument functions like printf, scanf and so on. So, makes it much easier to use. So, here is an example of type safety C versus C++. So, there are two types of two integer variables and one double variable. This is what I wanted to write for the integer %d, it prints OK. Here I have missed out on one %d, which can always happen, and I write 2. So, since it is missing and there are two values given, it prints the first one, it knows the %d. For the second value j, it does not know what is the format. So, it prints in some God knows in what format. A problem of the reverse kind can also happen. For example, you have written two format strings and but given only one input, which will not give you an error or garbage, but it will simply ignore. So, %d, it has got I, it has printed that. It does not have a second variable to print, so it does not do anything. Right? So, all these kind of errors are possible. What is even more dangerous is if you use a wrong format. You want to write the double value, you have to use %lf, it prints the value correctly. Suppose you have done it with d, it will not tell you anything, it will silently print something. What is it printing? It is I mean this entire double is interpreted, reinterpreted as if as an int in some way, and a negative value is generated. If you happen to do the reverse, you are trying to print an integer, but using the format for double %lf, you again get something meaningless. Right? So, all these errors will keep on happening. If you do it in the C++ style, there is no scope of error, because all these specifying the format, the order, the matching, correspondence between the position of the format string and the position of the variable, all these do not exist. So, you can just keep on cascading and it is guaranteed to work, it is safe, type wise it will always work. What is more is the type safety extends to user defined operators. This is just for your reminder. So, here is the operator for output, this is the operator for input, which I have defined for the complex class. You have seen this before, and here we have some complex class objects which we can cascade and write, then we can read into them using the read operator, and again write to check that you are getting the correct values. This is for completeness, because we have already discussed this, but for completeness in the context of the I/O, it is very important that it is type safety is not only available for the built-in types, but the same safety and the same syntax and the same cascading is available for any user defined type, which makes everything very uniform. Certainly, you can do unformatted I/O. There are member functions like read, write, get line we have already seen, total number of characters that you have done, and so on. Stream manipulators we have seen already. For example, we have seen how to flush the stream and so on, how to put a new line we already know. So, these you have seen. You can change the base also. You can say that I want to print this value in the hexadecimal base and so on. So, there are several manipulators like precision is something which is very important, because you can by precision you can say how many points after the decimal that you want. You can clearly say that by invoking the precision member function of cout and then basically stream to it, or you can use the set precision function as well. You can control the field width. These, I mean, there are number of them. You just need to, I mean, whatever you need, you just look up and apply that. The style is the same, that either you can invoke it as a member function on the stream object, or you can invoke it. You have it as a global function wrapper in I/O manip. For all this, you will have to certainly include the I/O manip library component. Right. Now, in the next couple of slides, I am not going to go through at all, because these are for completeness of information in terms of what are the different states that exist for formats of files, as well as in case of error states. So, those are just like data. So, there is nothing, no concept involved particularly. So, you can just look at them and refer to them as and when you need. Before I conclude, I will just summarize on the standard I/O library for C++. So, in terms of the organization, you can see that what we typically need to include is I/O stream and S stream if we want to do with strings, and F stream, or specifically IF stream, OF stream. You can do F stream itself like you are doing I/O stream, and I/O manip. Everything else like these all different headers are included through them. You do not directly need to include them, particularly as you do the application programs. This is the overall class hierarchy for your understanding. So, you can say that iOS base is what lies in the top, but iOS is the main implementation of the input output system, from which I stream and O stream both are separately inherited, and IO stream is multiply inherited from both, and then F stream and string stream come from them. So, that is how this whole structure goes on, and this is the complete diagram of classes and the different files. Remember, the blue ones are what you will need to include, the 4 IO stream, F stream, SS stream, S stream and IO manip. Others get included as it is. And this is the organization of the header for your reference, which includes which header. So, we have kind of taken a look at the object oriented style of IO in C++. We have seen how is it, how it gives us a very compact type safe mechanism which is extendable to user defined data types. Thank you very much for your attention. See you in the next module.